On the outer arches, the rock shears off cleanly, leaving behind a smooth wall. Dr. Worsey demonstrates NORAD's smooth wall blasting technique. With everyone at a safe distance from the site, it's countdown time.
Fire in the hole! 3, 2, 1!
The result, no collapse.
A nice, fairly smooth wall, and there's hardly any cracking on holes at all.
Fewer cracks mean a more stable wall, which is exactly what NORAD's blasters and engineers finally achieved at Cheyenne Mountain in the fall of 1961.
If they had not used these very innovative, carefully planned mining techniques, blasting techniques, the chances of having a facility that would survive a nuclear blast would have been minimal.
The excavation crews must still meet their deadline of June 1962. Blasters work in 3 shifts around the clock, 6 days a week. They must attack the mountain from both ends. The design plan calls for the 2 tunnel crews to meet at a central juncture point. There they will excavate the main cavity for NORAD's 15 buildings. On the south side of the mountain, one team bores the access tunnel for NORAD's ventilation system. It's 2,668 feet long and 17.5 feet high. On the north side, another team must blast out the MegaStructures main entrance. It's a shorter tunnel, 1,416 feet long and 22.5 feet high. Blasting, digging and carving out tunnels thousands of feet through a mountain takes time. The question on everyone's mind, can the command post be built before a Soviet attack? On August 13th, 1961, the Soviets start to build the Berlin Wall. 3 weeks later, they begin testing a whole new generation of nuclear bombs. For the workers at NORAD, it's a race to deter a hostile superpower. Just 3 months after their start date, workers hit a milestone. On October 7, 1961, crews from the north and south tunnels meet. Together, they've carved through 4,675 feet of solid granite. It is a monumental achievement. Yet the tunnels are just the road to the main event. Digging out NORAD's 7 central chambers. It's the toughest job so far. The crew has just 8 more months to finish the entire excavation phase of the NORAD megastructure. A daunting task. But in the heart of the mountain, where those chambers are being hollowed out, engineers hit another major obstacle. Rock boring samples of the granite reveal a critical flaw in the cavern's roof that threatens to derail the entire multi-million-dollar project. MegaStructures NORAD will return. We now return to MegaStructures NORAD. October 30th, 1961, the Soviets test the most powerful atomic weapon ever built, a 57-megaton Tsar Bomba. Nearly 4,000 times more powerful than the bomb dropped on Hiroshima 16 years earlier. The blast has repercussions halfway around the world. At Colorado's Cheyenne Mountain, where engineers are building a top-secret command post secure enough to survive a nuclear blast. Working around the clock, construction crews have carved out more than 6 million cubic feet of rock for NORAD's 7 central chambers. But 3 months into the dig, engineers uncover a dangerous weakness in the mountain's geological structure. Huge fractures above the 3 main chambers could cause the entire cavern to collapse from the vibrations of a small earthquake. Engineers must address this new risk or terminate the entire project. It's back to the original blueprints and a radical proposition. engineers decide to rotate the chambers 70 degrees and reposition the entire excavation project. In this new design, the cracks over the future buildings are now shorter, minimizing the effects of an earthquake or nuclear blast.
If they had not changed from the original plan for that portion of the excavation, it's likely that A, you would have had problems with caving rock, or B, if there had been a nuclear attack, the vibrations to the entire mountain would cause that to collapse.
With the revamped design, construction crews are now ready to carve out the 5 reservoirs. 4 of the reservoirs will hold a total of 6 million gallons of water, enough to fill more than 20 Olympic-sized swimming pools. A 5th reservoir will hold 500,000 gallons of diesel fuel. The surplus will run the 6 generators that provide NORAD's power. With the reservoirs completed, construction crews are just a few months away from their June 1962 deadline for excavation. But soon the mountain's natural elements present another challenge for NORAD's blasters. Engineers discover that large sections of the mountain are filled with water. So much, in fact, that miners can't possibly pump it all out. Too much water is a nightmare for blasters, creating fractures in the rock. Miners have no control over the way fractured rock explodes. Miners are forced to find another type of explosive. They try out a compound called slurry. Made from ammonium nitrate, slurry can be molded to fit any crevice, so it can fill a hole that is cracked. But blasting away tons of rock weakens the mountain structure. Engineers decide to secure NORAD's unstable granite roof with giant steel rods called rock bolts. Measuring from 6 to 32 feet in length, these metal dowels will provide critical structural support.
Rock bolts are really important in tunneling because they're a method of stabilizing the roof. We actually pin loose pieces of roof to stabilize them.
Workers install the steel rods into the walls and ceilings of the chambers. The tip of the bolt has an 8-inch split that holds a steel wedge. Compression drives the wedge into the steel rod, spreading its tip and anchoring the bolt against the surrounding rock. Crews insert bolts 4 feet apart throughout the chambers and tunnels. Each bolt is tightened against a steel plate on the surface of the rock. As miners continue to carve out more chambers, they uncover another natural element that is weakening the rock cavern around them. Volcanic rock called basalt. Softer than granite, basalt will deteriorate and fall apart when exposed to air. Miners decide to spray the rock with a concrete mixture called gunite. It hardens into a solid wall that prevents the granite from deteriorating. With all these unexpected complications, the construction crew struggles to stay on schedule.
People were working 6 days a week, basically around the clock, and they knew that national defense, possibly national survival, depended on doing this job quickly and doing it right.
Finally, on June 18, 1962, just 2 days after their deadline, workers finished the dig. Phase 1, excavating the mountain, is complete. Almost 1 billion pounds of rock had been removed from Cheyenne Mountain. Enough to fill 23,000 dump trucks. 8 months later, engineers are ready to start Phase 2 of this monolithic megastructure. Constructing NORAD's 12 personnel buildings and 3 industrial structures. 6 generators and a complex ventilation system must also be installed inside Cheyenne Mountain. But their plans are suddenly turned upside down. unexpected fallout from a dangerous new weapon. NORAD will return on MegaStructures. Welcome back to MegaStructures NORAD. July 1962. Construction crews working 2,000 feet inside Colorado's Cheyenne Mountain have carved out more than 5 acres of granite to make way for one of the most important megastructures in military history. The NORAD Mountain Fortress will be America's first line of defense against enemy threats. Phase 2 of the project is ready to begin. Engineers have already designed 15 buildings that can withstand a nuclear blast. But new advances in weapons technology are threatening to neutralize the whole project. On July 9, 1962, more than 200 miles above the Pacific Ocean, the U.S. detonates a high-altitude bomb in a nuclear weapons test. An unexpected byproduct of this explosion is a newly discovered phenomenon called an electromagnetic pulse, or EMP. An EMP generated 200 miles above Kansas could cripple the entire United States by preventing electronic devices from functioning. And NORAD depends upon electronics operating around the clock to successfully accomplish its mission of surveillance. Back at Cheyenne Mountain, engineers realize that thousands of feet of granite offer zero protection against an electromagnetic pulse. The one object that will ward off the destructive pulse is metal. Like a lightning rod, metal directs the electromagnetic pulse to the ground. But shielding all of NORAD's wires and computers in metal is impossible. A single gap in the shield, and the pulse could short out the entire complex. Just as engineers prepare to erect NORAD's buildings in February 1963, they brainstorm the solution. Construct the buildings entirely out of metal to ground the path of the pulse. Thick steel walls are brought inside the structure in sections, the only way to fit them through the tunnel opening. After they're inside, they're welded together at the seams. These steel walls will protect NORAD's sensitive electronic systems by transferring an incoming electromagnetic pulse through the metal to the ground, where it will be absorbed and neutralized. Actual construction on NORAD's steel buildings starts in March of 1963. But 7 months later, the engineers hit another wall. They determine that a geological fault in the roof of the main chamber will not withstand a nuclear detonation. They thought this problem had been solved when they pivoted the planned structure almost 2 years ago during the excavation phase, but they were wrong.
Even though they reoriented the complex, there was still a crack over a part of that complex, and that caused a great deal of concern.
Under this crack is the proposed site of NORAD's most important building, the command center, home to crucial monitoring and surveillance systems. So engineers come up with a new plan. They will install a giant concrete shell, 50 feet in diameter, just inches below the main chamber's granite ceiling. Its purpose? To protect NORAD's future 3-story command center from being buried by tons of crumbling rock. The enormous dome, ranging from 4 to 14 feet thick, is made from steel-reinforced concrete. It will be supported by 4 massive 3-story high concrete columns. It's so large that it has to be fabricated outside the mountain and transported through NORAD's tunnel entrances in pieces. Workers use hydraulic jacks to reassemble it inside the mountain, lifting it into place on top of the columns. To stabilize it further, the dome is fused to the cavern ceiling. 6 months later, the dome is assembled and in place. The construction of NORAD's main buildings is now the top priority.